Okay, so let's go over some of the homework that you had last night. Number 25 is a little bit different than some of the other ones we did. So let's talk about the driving test. You're about to take a road test for your driver's license. You hear that only 34% of the candidates pass the test the first time, but the percentage rises to 72% on subsequent retests. Because most teenagers really want to drive, they keep taking the test until they passed. Create a plan for a simulation to estimate the average number of tests drivers take in order to get a license. So our plan is going to be, so what are we simulating? We write that down first. Taking a driver's test, and this is the road test. We have to set up what numbers we're going to use. So for the first attempt, that's going to be different. And then second plus attempts. Anything after the second attempt has a different percentage. So for the first attempt, 34% of students pass. So 0 to 33 is pass, and 34 to 99 is going to be fail. If you don't get a pass on the first time, you have to take it again. And if you take it again, you have a 72% chance of testing or passing. So 0 to 71, remember we're including 0, so we go from 0 to 71 instead of 1 to 72. And then 72 to 99 is fail. Okay, so we're going to use a random digit table, 2 digits at a time. Or use randint 0, 99. Okay. If the first test is a pass, trial is over. If the first test is fail, we continue till we have a pass. We record the number of attempts it takes to pass. So that's step 3. Step 4, what's our response variable? It's the average number of attempts. Histogram shows the results of 100 trials of a simulation. Use these results to estimate the average number of test drivers take in order to get a license. So it's not actually asking you to do the simulation. It's just asking you to create a plan for it. And then 27 asks us to use this information again. So if I'm using the simulation, the average number of tests drivers take, so 1 was 32, so 32 times 1 attempt plus 27 times 2 attempts plus 15 times 3 attempts. Because that means you have in your data 32 ones and 27 twos and 15 threes and 7 fours. So 7 fours plus 4 fives plus 7 sixes plus 4 sevens, 3 eights, and 1 9. We can add that up and divide it by 100. Let's see what we get. 32 plus 27 times 2 plus 15 times 3 plus 7 times 4 plus 4 times 5 plus 7 times 6 plus 4 times 7 plus 3 times 8 plus 9. So I got 282, so that adds up to 282 divided by 100. So that's 2.82 average. So based on this simulation, not ours. We haven't done it yet. We're looking at the simulation that was done below. Okay, so based on this simulation, it can be expected to take approximately an average of 2.82 attempts to pass the driver's test. Right, or an average of approximately 2.82 attempts to pass the driver's test. So then we go to number 27, which is trying to just get this piece and move it. There we go. I haven't used it yet. Okay, 27 says still learning. We're looking at exercise 25 again. As in exercise 35, assume that the chance of passing the driver's test is 34% for the first time and 72% for subsequent retests. Estimate the percentage of those who tested who still do not have a driver's license after 2 attempts. So we want to know what percentage, okay, so this is going to be a yes-no type thing. What percentage have not passed? Okay, so we're going to add up all the no's. So we're still going to let first attempt 0 to 33 be pass, 34 to 99 be a fail, second attempt 0 to 71 pass, 72 to 99 fail. And so we're going to use a random digit table, 2 digits at a time. Let's see. Recording if the student passed the test by second attempt. Our response variable is the percent of students who have not passed after 2 attempts. So remember that the way you explain your trial needs to help me perform it, just like you did. So the first test, so we may need to add in that information first. Test, pass, trial's over, record a yes, second test, pass, that's a yes, second test, fail will be a no. So let's look. I think we probably want to go to like, well, I'm just going to say line 112. I don't know. It doesn't matter where we start. But we're going to start there. We're using 2 digits at a time. So 59 is a fail. So the first attempt was a fail because remember we're looking at 0 to 32. No, 33, sorry. And then 34 to 99 for the first attempt, and then 0 to 71 and 72 to 99. So we, after the first attempt, so we got a fail on the first attempt. Now we're looking at this set of numbers. Is it between 0 and 71? And 63 is, so the second attempt is a pass. And so that means my first trial is a yes, because that person passed in 2 attempts. So the next number is 68, which is a pass. It's a pass. And then 88 is a fail. So that, no, my bad. Back that up. 68 is not a pass because we go back to the 0 to 33 and 34 to 99. So this is a fail, and then 88 is a fail. So then this trial is no. Second, next one is 04. That's a pass. So that's the end of the trial, and that's a yes. And then my next number is 04 again. That is also a pass. So that's a yes. Passed it in one attempt. The next one's 63. That's a fail on the first attempt, 0 to 33. And then the next number is a 47, which makes it a pass because that's between 0 and 71. And so that's a yes. 11 is a pass. So that's yes for that trial. 97, fail. And then 19 is a pass. So that's a yes. And the next one, 35, fail. And then 27 is a pass. So that trial is a yes as well. We'll do 10. 1, 2, because it doesn't tell us. So 1, 2, 3, 4, 5, 6, 7, 8. So I need 2 more. So the next number is 30. That's a pass. So that's our 9th trial, and that's a yes. And then 89 is a fail, and 84 is also a fail, so that's a no. Okay, now I want to know how many didn't, the percentage that did not have a license after 2 attempts. So we're counting up how many no's we got. So I have 1, 2 no's. Okay, so you would be just writing down on your paper, yes, no, yes. Last one was a no. And so that means 2 out of 10, 20%. So based on my simulation, I would expect approximately 20% of students to not have a license after 2 attempts. Okay, so then we're going to come over here. I'm going to take a picture of number 28 and part of 29 there. 28, a person with type O positive blood can receive blood only from other type O donors. About 44% of the population has type O blood. At a blood drive, how many potential donors do you expect to examine in order to get 3 units of type O blood? So what are we simulating? Blood donation. We're going to let 0 to 44 be, 43 be type O blood, and let 44 to 99 be other types. So we're going to use a random digit table. 2 digits at a time. Until 3 type O pints are gathered. Okay, so we're going to record number of total donors to get the 3 pints. So my response variable is the average number of donors it takes to get 3 pints. Okay, so we're going to go back to our random digits. I'm going to skip a line. I'm going to do 114. So 0 to 43 and 44 to 99 were our numbers. So that's an O and that's a not O. So we'll circle it if it's an O, we'll put an X on it if it's not. So 45 is between 44 and 49, so that's an X. And then 14 is an O. 93 is an X. 29 is an O. 92 is an X. 75 is an X. 73 is an X. And 6 is an O. So I have 3 O's now, and how many did that take? It took 1, 2, 3, 4, 5, 6, 7, 8. So my first trial is 8. My next trial, 62 is an X, 80 is X, 3 is an O, 81 is an X, 95 is X, 62 is X, 2 is O, 2 is O. I can end my trial. It took 1, 2, 3, 4, 5, 6, 7, 8 again. So this trial is 8. Do it again. 93 is an X, 87 is an X, 9 is an O, 15 is an O. We'll go to the next line. 61 is an X, 4 is an O. So that's the end of that trial. It took 1, 2. Let's move this over. Let's go back. Where was it? 1, 2, 3, 4, 5, 6. 5, 6. So we're going to write 6. Okay. Now we're going to do our next one. 17 is an O. 76 is not. 84 is not. 94 is not. 32 is an O. And 22 is an O. So I have 1, 2, 3. And then I had 3 O's and 1, 2, 3 X's. So 3 and 3, 6 again. We'll do it again. 47's not an O, 9 is an O, 73 is not, 69 is not, 81 is not, 45 is not, 26 is, and 31 is. So that's 1, 2, 3, 4, 5, 6, 7, 8 again. That's the end of that trial. And you'll need to do this 5 more times. Okay, for the sake of time and this being on video, we're going to add this up and divide by 5 to find our average. So 8 plus 8 plus 8 is 24 plus 12. That's 36 divided by 5, which is 7 and 1/5, so 7.2. So that's our analyzing our response variable. So it was 8, 8, 6, 6, 8, and that was 36 divided by 5, 7.2. So based on our simulation, we would expect an average of 7.2 donors to collect 3 pints of type O blood. Okay, and the last one from last night's homework is 29, which starts out by saying, it's up a little bit up here somewhere. To attract shoppers, a supermarket runs a weekly contest that involves scratch-off cards. With each purchase, customers get a card with a black spot obscuring a message. When the spot is scratched away, most of the cards simply, and then we'll go back here, say, sorry, please try again. But during the week, 100 customers will get cards to make them eligible for a drawing for free groceries. 10 of the cards say they will be worth $200. So 10 are worth $200, 10 more are worth 100, 20 are worth 50, and the rest could be worth $20. To register those cards, customers write their names on them and put them in the barrel at the front of the store. At the end of the week, the store manager draws cards at random, awarding the lucky customers free groceries in the amount specified on their cards. The drawing continues until the store has given away more than $500. So at $500, that's not enough. They're going to pick another person to give away to. Estimate the average number of winners each week. So again, what are we simulating? We're simulating a drawing for free groceries. We're going to let 0 to 9 be worth 200. That's 10 numbers. 10 to 19, 10 more numbers are worth 100. 20 of them, 20 to 49, or 20 to 39, are worth $50, and the rest, 40 to 99, are worth 20. Okay, so we're going to use this time randint. 0,99. Adding up total amount given away until it exceeds $500. We're going to record the number of winners. Okay, so our response variable is the average number of winners each week. Okay, so this one we're going to do in this video. You should always do at least 3 trials. For the sake of a video not being super, super long, I'm going to do 3 trials. Okay, and this one's a little bit longer. So remember, it's math, probability, randint. So remember, it's the math button. We go over to probability, and it's randint. 0 to 99. I'm just going to ask for 1 and paste. Okay, so I'm going to put this off to the side, the video, and then we're going to write down how much money we're giving away, because we need to total that up, and then at the end count how many people won. So 34, let's put this over here, 34 is $50. So for trial 1, it's $50. Okay, that's the first outcome. 53, $20, because that's between 40 and 99. 42, $20. 19, that's 100. So right now we're at $190. 11, another 100. $290. 30 is 50. $340. 79 is between 40 and 99, so that's $20. 16 is $100. So far I have 100, 200, 300, 400 with the 50s, and 320s. That gives me 460. So I got to keep going. 5 is 200. Now we're at a total of 660, so my trial is over. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 winners. And then we start our next trial. Okay, so our first number is 89, that's $20. 75, $20. Oops. 38, $50. So again at 90, 61, 20, 110, 47, 20, 130, 2, 200. 0 to 9 is 200. So now we're at, I forget where we were at. 80, 330. 75 is 20, 350. 32 is 50. I lost track again. 1, 2, 3, 4, 5. So 300, 400. So we're at 400. 38 is another 50, 450. 2 is 200. So we said 450, that's 650. So how many total winners are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we'll do that one more time and we'll average them. This is a lot like the AP problem we looked at yesterday. The radio station, 41, $20. That's between 40 and 99. So that represents $20. 63 is between 40 and 99. Represents $20. 34, 20 to 39 is 50. 86, 20. 89, 20. 18. 18 is 10 to 19, so that's 100. 16 is another 100. 10 to 19. 20 to 39 is another 50. So we're 100, 200, 300, 80. So we're at 380. 64 is another 20. So that's 400. 38 is 50, 450. And another 50, 500. But it says exceeds, so we're going to go one more. Another 50, and that's 550. For how many winners? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 winners. And obviously, if you're using your calculator, you're going to get totally different numbers. If you're using a random digit table, you're going to get different numbers. I'm going to do 3 for the sake of time. You need to be doing 10 every time, unless it tells you otherwise. So that's my response variable is the average number of winners. So 9 plus 10 plus 12 over 3. It's 19, 20, 31 over 3, 10.33. So based on our simulation, I would expect an average of 10.33 winners each week if over $500 is given away.